Hi, it's time for the Laplace transforms practice test answers. And man, if you stayed tough and did that practice test, I salute you and you are in good shape. You've had the experience, the essential experience of struggling through a Laplace transforms problem that isn't nice. And so if I give you a nice one on the test, you'll be done fast. So here we go with the first part of the answers. In part A, I'm saying you took the answer you got from Laplace transforms and put it back into the equation. You should get the right-hand side equaling the left-hand side. You should get a true statement. You're actually checking the problem. Letter B, just use the table straight out. Letter C, slightly tricky because you have that extra factor of e to the negative 8s. So when you have an e to the negative 8s times 1 over s plus 1, you got to spot the 1 over s plus 1 and realize that the inverse transform goes with e to the negative t. However, that extra factor means you got to use this line. You have to think of the inverse transform of this product. You have to. There's no other way to do it. You can't do it term by term. You have to do it as this product. So it's that line. So you spot this structure and you spot that this guy goes with this guy. You know, this pair goes together here. However, when you see this line in the table, there's an offset on the power. Or actually, every occurrence of t in your big Y has to have that, actually it'll be little y when you do the inverse transform. Every t in the little y part has to have that offset of t minus, in this case, 8. So you have to have the u sub 8 and that thing. So I just thought I'd point out to you, and you should be, this is one of the little things to know. There's a little a in the table for this line. This little a goes with this little a. All these guys go together. But it's not the same little a as the little a you get from the u sub a. Or in this case, the e to the negative 8s. You know, that's a different little a. It's a different line of the table. Different line of the table, different little a. I'm sorry the book has chosen to use the same letter in two different lines for two different things. You've got to get used to that idea. Okay? And now for the other problem. Holy son of a gun. It exploded. There's Laplace transforms all over the place. We take the differential equation and we hit it with Laplace transform. So y double prime becomes all this. All that is just the inverse, or sorry, the Laplace transform of y double prime. Those three terms. Then the Laplace transform of y prime. But it's times a negative 3. Don't forget that part. And I ran out of room going across. So this is the continuation, negative 4 times the Laplace transform of y, and then the Laplace transform of 1 over, or e to the t, 1 over s minus 1. All right, so now you know what to do. You get the Laplace transform of y times all the stuff that is, been factored out, and this should echo back to this structure, and it does. That's good. And now all the other leftovers on this side, and then you divide everybody by s squared minus 3s minus 4. So now you got the Laplace transform equals this mess. And you have 3 partial fractions to do. Three partial fractions to do. That takes up a whole piece of paper. Welcome to your next test. You're going to have to do these kind of things. So here's how it turns out. It just keeps getting better. The partial fractions results are here. So partial fractions for this first thing, I actually got whole numbers. The other ones are all fractions. Partial fractions here. And then this guy with the 3 factors, we'll do that partial fractions after this, just to show you what I expect you to see. This guy breaks up into 3 terms. There they are, those 3. And you've got like terms. You can combine them now or combine them later, whatever it is. What I did was I hit it with the inverse Laplace transform. So the 2 over s plus 1 becomes 2 times e to the negative t. There's a couple more s plus 1s, a 19/5 e to the negative t, and way over there a 1/10 e to the negative t. So I did a lot. I did the sorting and the inverse Laplace transform together. It's whatever way you do it. Just keep track of everybody. You lose one thing, and your answer won't check. So anyway, you get over here. These are the e to the 4t pieces. So I'm looking for the s minus 4s downstairs. There's 3. And here they are. And here's what I did. I actually pretended to be you. You don't have to do this. You know, you can do it your own way. But what I did was I took the original problem and solved it using back old ways, y sub h and y sub p. So this is over here. I used y sub h and y sub p. So here's the answer I got that way. You can see it over here. And if you use your calculator or just do the work getting the common denominators yourselves, oh, that's a 19/5, not a 15th. 19/5. Anyway, do this thing here, and you will get 177 over 30 for that first thing. They're the same thing. You will get the 64 over 15. These guys are the same thing with that correction made. And then this guy is the only one of its kind. He's from the forcing term. He matches okay. So next up, I'm just going to do real quick one of the partial fractions, the worst one, the triple. So here's something I'll be looking for. Did you do your algebra? Because what the Laplace transform story, you guys, the Laplace transform story is kind of weird. You take a differential equation, you hit it with the Laplace transform, and then you do algebra. You do pre-calculus, usually partial fractions and some other stuff. So you do that stuff and you solve for L bracket Y, and then you hit it with the inverse Laplace transform. And you hope that each term can be turned into the inverse Laplace transform or whatever you have. And that's why the partial fractions are all over the place, because we don't have a table that takes care of products in the denominator for us. So we have to break them up, break up the fractions into single fractions, and then we can hit each term. So here's what the first thing looks like. I'm only working on this piece, just this one piece, but I'm going to get 3 terms: a over s minus 1 plus b over s minus 4 plus c over s plus 1. Multiply through by the denominator, so this denominator cancels and I get a 1. See it? Okay, good. And then on this side, you're going to have a times s minus 4 times s plus 1. So that's as squared minus 3a s minus 4a. Then I'm going to have b times s minus 1 times s plus 1. So that's s squared minus 1, so bs squared minus b. Then I have c times s minus 1 times s minus 4. So that's this piece here, c s squared minus 5cs plus 4c. Now, you do the s squared, you do the s, and you do the constant. And the constant is equal to 1. So what I spotted right away was this little equation only had a and c in it. So I get this quick relationship for substitution. Substituting into here and into the last one, I get these two circled expressions, and I can combine those. And what you can notice, if you add straight down, you can cancel the b's. Just add this line to that line, the b's cancel. And that gives me 30 over 3c equals 1, so c is 1/10. And then you take that 1/10 and you pop it in here and you get a. You take what you get for a and c and pop it in here and you get b. And then you have the numbers that I had on the board before. So, whoa, what a long problem, and good luck, on Thursday night. Bother me with emails, and I'll be glad to chat with you about this sort of thing. Try some more book problems, but I'm not out to get you. I'll give you better numbers than this. But as far as a practice test goes, I hope you took a page or two to do this, because then you paid your Laplace transform dues.